Let's solve more examples of first order partial derivatives. Now we're given if y is equals to sine xy, it will show that 1 over y partial derivative of z with respect to x is equals to 1 over x partial derivative of z with respect to y. Now the first thing to do is to evaluate both dz dx and partial derivative of z with respect to y. Therefore, let's start with partial derivative of z with respect to x. Now we will understand that y is kept constant. Okay, so that is sine x y. Now we recall that whenever we differentiate with respect to x of cos ax, or let's say sine of sine ax, we will have a cos ax. And now our a in this case is similar to y because a is kept constant, right? So our answer of partial derivative with respect to x will be equal to y cos ay. Cos xy rather. And our partial derivative with respect to y will be the differential with partially with respect to y of sine xy, where our x is kept constant. Now we recall again that whenever we differentiate cos ax, but we don't need this. Whenever we differentiate sine ax, we have a cos ax. Now since our x is kept constant, our x is similar to a. Therefore, this will give us x cos xy. Now we now understand that partial derivative of z with respect to x is y cos xy, and partial derivative of z with respect to y is x cos xy. And we are asked to prove that this is valid. That's 1 over y dz dx is equal to 1 over x dz dy. So let's make our substitution. This is 1 over y dz dx is y cos xy, 1 over x dz dy is x cos xy, and we have cos xy to be equal to cos xy. Therefore, we can now say that 1 over y partial derivative of z with respect to x is equal to 1 over x partial derivative of z with respect to y. So let's take another example. 2. We recall for gas constants or gas expressions in ideal gas equation that PV is equal to mRT or sometimes nRT, and P is given as mRT over V. Now we are given this expression and we are asked to evaluate a partial derivative of p with respect to t and partial derivative of p with respect to v. Now with this done, let's start with partial derivative of p with respect to t. Therefore, in this case, our v is kept constant because we know that p here is a function of both temperature and volume. Therefore, when our v is kept constant, we can have our expression of v of p to be m arc over v multiplied by t. Therefore, our partial derivative of p with respect to t is m arc over v multiplied by the differential with respect to t of t. Now this is m arc over v multiplied by 1, and our answer will be m arc over v. Now for our partial derivative of p with respect to v, that means we are saying that we are keeping temperature constant. Therefore, we can write our expression of p putting temperature as constant. We have m arc T multiplied by 1 over v. And we can rewrite this as m RT to v raised to power minus 1. Therefore, the partial derivative of p with respect to v is m RT differentiating v raised to power minus 1 with respect to v. And with this, we have m RT multiplied by minus v raised to power minus 2. And this can be written as minus m RT divided by v squared. Finally, for this video, let's take another example. We're given v is equal to 1 over 3 pi r squared h, and this is the volume of a cone. And we know that v here is a function of both r and h. Now let's find expressions of the v, the h, and likewise of the v, the r. You can pause the video now to give it a try. Now let's begin with partial derivative of v with respect to h, and in this case our r is kept constant. Therefore, we can write our expression of v to be 1 over 3 pi r squared as a constant multiplied by h. Therefore, the v, the h, will be 1 over 3 pi r squared differentiating with respect to h of h, and this will give us 1 over 3 pi r squared multiplied by 1, and that is 1 over 3 pi r squared. Evaluating the v, the r, and that means that our h is kept constant. And if the h is kept constant, we can write our volume as 1 over 3 pi h as a constant multiplied by r squared. Therefore, our partial derivative of v with respect to r is 1 over 3 pi h as the constant multiplied by the differentiation of r squared with respect to r. So this will give us 1 over 3 pi h multiplied by 2r, and in short we are going to have 2 over 3 pi r h.